Hi, in this video I'm going to go through question 35 on section 1 of ECAA 2018. So this question, they give us the equation for a cubic, where the b, c, and d are constants, and we're told that two of the factors of this cubic are x minus 1 and x plus 1. Then we're asked which of these three statements, when taken independently, must be true. Alright, so let's look at our first statement. So if f of 0 is equal to k, then f of k is equal to 0. Well, if f of k is equal to 0, then k is the root of f. So how are we going to find the roots of f? Well, we're already given two of them, right? Because we're told two of the factors. And, well, how many linear factors can a cubic have? Only 3. So if we have two of them, then we can actually factorize f completely. So we can write f as x minus 1 times x plus 1, so these two factors, times x minus a, where a is just the third root, and we don't know what that is yet. Alright, so we have these two representations of f. Now f of 0 is just the y-intercept, and from this representation of f we can see that's going to be d. So f of 0 equals k means that d is equal to k, so f is x cubed plus bx squared plus cx plus k. And does this imply that f of k is equal to 0? Well, if k was plus or minus 1, that would be easy because plus and minus 1 are roots. But if k wasn't, then we'd need this a to be equal to k. So can we show that a is equal to k? Well, let's expand this out so that it looks in the same form as this. So I'd get x cubed plus some x squared term plus some x term, and then for the constant term we have minus 1 times plus 1 times minus a, so that would be plus a. And now if we compare the coefficients in these, we see that actually, yeah, a would be k. So we would get that k is one of our roots. So if f of 0 is k, then f of k must be 0. So this first statement must be true. Now, for the second statement, f of x is equal to x cubed minus x. Let's write this in this way. So if I factorize that out, I can take an x out, then have x squared minus 1. And the x squared minus 1 is the difference of two squares, so that would give me the x plus 1 and the x minus 1. So this is saying that our third root must be 0. So is there anything to say that our third root a must be 0? Well, no, I don't see why it'd have to be 0. For example, we could draw a cubic like this, so that our third root was greater than 0, or could have it less than 0, or we could even have a cubic with a repeated root. So there's nothing to say why our third root must be 0. So this second statement doesn't have to be true. Now, this third statement is actually probably the easiest one. So it says the graph of f of x is symmetrical in the y-axis. So it basically says it has to be symmetrical in this vertical axis. But f is a cubic, right? And it's a cubic with a positive coefficient in front of the x cubed. So it's always going to go from bottom left to top right, like all of these that I've drawn here. So really, you wouldn't even expect f to be symmetric in the y-axis. And none of these examples that I've drawn are. So no, 3 doesn't have to be true. So we have that only 1 must be true. So that gives us answer B.